Could we be getting closer to a mass-produced quantum computer? The steps Quix Quantum is taking to scale up its latest tech. Mixing photonics and electronics has been a challenge for many, why one research team believes they've conquered those hurdles in a first-of-its-kind chip. And the final reports from Munich are in, was growing optimism from the laser community enough to break attendance records? These stories and more on Photonics Spectra Now. Photonics Spectra Now is brought to you by Thorlabs, pioneering photonics technologies to accelerate research and development. Visit thorlabs.com to learn more. Hi, and welcome to Photonics Spectra Now, covering your top headlines in the world of photonics. I'm Joe Kaczynski, a senior editor with Photonics Spectra. STMicroelectronics and Metalenz have entered an agreement that could lead to major advancements in metasurface optics. The semiconductor developer can now use Metalenz tech to produce metasurface optics on 300mm semiconductor wafers. Officials with STMicroelectronics say this partnership bolsters its position in the consumer, industrial, and automotive sectors and has the potential to redefine the sensing ecosystem. Quix Quantum has raised more than $17 million on its quest to deliver its first-generation universal photonic quantum computer. This computer is designed to implement a universal gate set that would enable any quantum operation. Built on silicon nitride chips, this machine is ready to be mass-produced and can operate at room temperature. Quix Quantum says this system is already fully compatible with most data center environments. In personnel headlines, Scott Carney has been named chair of the Department of Mechanical Engineering at Stony Brook University. Carney served 4 years as director of the Institute of Optics at the University of Rochester starting in 2017. And he served as chief scientific and technology officer at Optica, where he led the government affairs team. He also co-founded Diagnostic Photonics Inc., a medtech company that developed a handheld, high-resolution imaging system for cancer surgery. Researchers are calling it a first in lasers, as a team from the University of Illinois achieves photopumped lacing from a buried dielectric photonic crystal surface-emitting laser emitting at room temperature and at an eye-safe wavelength. These lasers, known as pixels, are a type of semiconductor laser that uses a photonic crystal layer to produce a beam. These systems have proven very useful in defense applications like LiDAR for navigation and target tracking. Typically, pixels are created using air holes, which over time can compromise the structure of the photonic crystal. By burying the silicon dioxide in the chip, these researchers were able to avoid the issues created by those air holes. Scientists from Northwestern University, Boston University, and the University of California Berkely say they've built the first photonic quantum system into a traditional electronic chip. This silicon chip combines quantum light-generating components with classical electronic circuits, all packing into a device measuring in at 1 square millimeter. And thanks to a built-in smart system, the light within that system is kept perfectly stable. With the ability to electronically control the system, scientists can stabilize quantum processes in real time. And it seems like just yesterday we were reporting from Munich for Laser World of Photonics. Now we're going back to Germany for a breakdown of the final reports from the show. Organizers said it was expected to post record-setting numbers, and the 1,398 exhibitors in attendance was in fact the most ever at the trade show. Roughly 44,000 visitors came to Munich to take part. Along with the demonstrations held by companies, guests were able to witness the power of the synergy between photonics, quantum technologies, and robotics. Running in parallel with the trade show, Europe's Photonics Congress also hosted 2 Nobel Prize winners to touch on the state of the industry. And even with international turmoil, the overall message was one of optimism. Now, these are just some of the bullet points from Laser World of Photonics, but you can read a complete recap of the show from contributing editor Andreas Thoss, covering everything from the energy on the showroom floor to in-depth analysis of the laser market to a review of booth parties from exhibiting companies. Just go to photonics.com and click on the latest news tab. Have news you'd like to share or suggestions for our team? You can send any story tips, questions, or comments to video@photonics.com. Give us a like and click that subscribe button in the corner for all the latest videos from Photonics Media, and be sure to follow us on all your favorite social media platforms. Remember, you can always find more details on these stories and everything else happening in the industry by going to photonics.com. I'm Joe Kaczynski, and thanks for watching.